Hi, today I would like to talk about why the length of the day is 24 hours, but the Earth only takes 23 hours 56 minutes and 4 seconds to complete one rotation. To understand this, let us do a thought experiment. Imagine that one night you look up the sky and you look up a set of stars. If you pick one star and know its spot on that particular night, on the next night that same star would be found at the same spot, and the time it would take for that star to come to that spot is 23 hours 56 minutes 4 seconds. But if you were to repeat the same experiment with regard to Sun, which is also a star, except the fact that it is the closest star to Earth and the Earth orbits it, unlike with respect to other stars, and observe the sun at a particular location at a certain part of the day, after 23 hours 56 minutes 4 seconds, the sun would not come to the same spot like the star in the night sky did. The sun would take 4 minutes extra to come to the same spot it had been on the previous day when observed from the same location. Now the big question is, why is there a 4-minute delay to spot the sun at the same spot from the same location compared to spotting a star in the night sky while carrying out the same experiment? Let me answer that question. Think that there is an imaginary line drawn from the observer to the center of the sun. It's a known fact that the Earth revolves around the sun and elapses an angle of about 1 degree each day while it's moving along its orbit. This angle we can get by taking the ratio of 360 degrees, the angle through which the Earth revolves around the sun, and the number of days it takes for the Earth to complete that revolution. So 360 degrees by 365.25 days, that is equal to 0.985 degrees. It's almost 1 degree, as I mentioned. While the Earth moved through this 1 degree along its orbit, the Earth had also completed one rotation. And the one rotation, actually, I told you that it does not take 24 hours but 23 hours 56 minutes 4 seconds. At the end of this time, the imaginary line that joined the observer with the center of the sun will still be there from the observer, but it won't point towards the center of the sun. So this line will be parallel to the original imaginary line that was drawn from the observer to the center of the sun, but won't point towards the sun. After 23 hours 56 minutes 4 seconds, one can draw a second imaginary line from the observer to the center of the sun, and only when the first imaginary line merges with the second imaginary line is it possible that the sun can be found at the same spot it was found the previous day from the same location. After having completed 23 hours 56 minutes 4 seconds, the Earth has started its next rotation, and while doing this, after 4 minutes, the first imaginary line would merge with the second imaginary line, and only then can the observer see that the sun had come back to the same spot in the sky as it had been the previous day when observed from the same location. In other words, if the Earth had moved through an angle of 1 degree along its orbit in a day, it has to cover that 1 degree again, and it does it through its rotation. The rotation, when viewed from the North Pole, happens from west to east or in the anti-clockwise direction. The revolution of the Earth around the Sun also occurs in the counterclockwise direction when seen from the northern hemisphere. Only when the Earth had rotated back that 1 degree in the counterclockwise direction will the observer be able to see the sun at the same spot that he had seen the previous day from the same location. And to rotate through 1 degree in the counterclockwise direction seen from the North Pole, it takes around 4 minutes. It takes around 4 minutes because one rotation is 360 degrees, and it takes 23 hours 56 minutes and 4 seconds to complete a rotation. So the ratio of 23 hours 56 minutes and 4 seconds and 360 degrees is 3.988, which is almost 4 degrees. If one had added the extra 4 minutes to 23 hours 56 minutes and 4 seconds, and one would get the time to be around 24 hours. This time, when the observer is able to see the sun at the same spot on 2 consecutive days, is taken as the length of the day, which is also called a solar day. The day corresponding to the actual time it took for the Earth to complete one rotation, that is 23 hours 56 minutes and 4 seconds, is called a sidereal day because the measurement of this day happens with respect to the stars in the night sky.